So I give a basic introduction to circularity. When I talk to my clients, I always use this slide as basically as the idea that there's no such thing as just a purely sustainable material. This is a Boeing Dreamliner. It's a very horrible material, carbon fiber, yet because of its use, it means that you have significantly less jet fuel. So therefore, as a result, it's a much more sustainable solution than aluminum or titanium. So the idea is more that use materials in the right way and they become a sustainable solution rather than just assuming that because you're using something that contains recycled content, it's better. So always think about the material in concert with the rest of the environment and how it's used, how it's shipped, how its end of life, rather than just assuming, oh, I'm using recycled content, so it's better. I know that Ren will talk a little bit about circular economy, but I want to at least also mention that there's a difference between circular economy and sustainability at the moment, and certainly in the way that we're approaching it. The image of the image shows basically a paper-based solution and a styrene-based solution. Now, of course, if you are thinking about circularity, circularity, then the ideal would be a paper-based solution because, of course, you can recycle it. But in terms of overall carbon footprint, overall impact on the environment, you should go with the styrene every time. So there's a slight difference between wanting a circular economy, something that has materials that go in circles, rather than something which is the lowest carbon footprint. And we're currently fighting in the sustainability world between these two, in that we want both. But sometimes when you find in things such as cosmetic packaging and other areas where they're trying to move away from plastics because they're concerned about their end of life, moving more towards paper, but then of course the carbon footprint goes up. So circular economy isn't always exactly the same. Sometimes carbon footprint is the one you're searching for, sometimes circular economy, but at least an understanding that they're not always the same. And if you're looking for something which has a circular solution, often initially you'll have a slightly increasing carbon footprint. Again, this is sort of where Ren will be talking, but if we think about circularity, it's all about ensuring that the materials we're using can perhaps go into a biological cycle or a technical cycle, so they can go in a circle rather than just in a linear process. So I'll talk about a range of different material types, from some basic construction materials through to perhaps materials that perhaps are more surface-based, and give you an understanding of where we are. So we look at wood-based materials. Basically, we still understand that even though wood has had some challenges where we're sourcing it, we know that basically it is a good choice for long-term use. Certifying is always better. One of the challenges we have, of course, is that if we start putting glues in there, the plywoods and the MDFs, that then becomes a circular challenge, because I know I can recycle wood. I can break wood down and recycle it using a wood chipper and then put that into another product. I can't do that with MDF and plywoods. That's one of the challenges we have when moving towards circularity. Wood-based products are a great solution, but understand that if I'm using plywood or MDF, I want to reuse that. I can't simply just recycle it. It doesn't recycle well. Plywood, we know, however, does have, it doesn't contain recycled content, doesn't really have any chemicals of concern, but we do understand that one of the challenges it has is that it does contain these glues, and these glues for the longest time have been a petroleum-based or plastic-based glue. So, I mentioned we can't really recycle it, but if we are going to implement this product, then it's best to try and not coat it, not basically glue it together with anything else if you can avoid it. So one of the biggest challenges we have with a lot of the materials that we work with is that they, as soon as you apply it, stick it to something else, you lose the ability to reuse it. So circularity determines that we should probably put materials together, perhaps in mechanical ways or ways in which they can be separated at the end of their life. So there's potential for end of life, second life. Generally, though, in plywood, one of the biggest advantages we've seen, though, is this use of bio-based binders. So if you look at this table, we're going to be using these tables as I go through. And you can see here we've got 3 different examples of this new solution in plywoods where we're using a bio-based binder. Typically, your current plywood that you purchase from or standard outlets will have a plastic binder. So if we're looking for something that has zero plastic, potentially could biodegrade eventually at the end of its life, then using these bio-based binders is a good thing. It has challenges with circularity, as I mentioned, because it can't be recycled easily, but at least we're starting to see with the Wisa Biobond, Neolineo, and also Rico Ecological, they're all using a bio-based binder, which is a step forward. If we look at MDF, the same challenge we have. It doesn't recycle easily. And unfortunately, even though there is the potential to put bio-based binders into MDF, no one's really doing it at the moment. We're still sort of in the early stages. These resins and binders that are bio-based have only just been created, and they're going into plywoods initially. They haven't quite managed to find commercially available versions of MDF that do the same thing. Again, it does have an overall a higher environmental impact overall than solid wood. And there have been some steps to actually recycle MDF. There are some pilot plants around. There's one in the UK at the moment where I'm presenting from right now that does have the ability to take the glue out of the MDF and then reuse that the fibers. We can do it. It's using a microwave process. It's interesting, but it doesn't actually, it doesn't give us the ability to do that in large volume yet. It's just a pilot plant. So there is the potential to recycle some of these panels, just not quite yet. 3 examples I thought were great was the New Green, I think, EcoBoard and Eureka. Some of these are actually using alternatives to wood. The EcoBoard and the Eureka are using wheat waste, and then also using rice chaff as well. So there are actually now alternatives to MDF that don't use wood. Not necessarily better not using wood, but they are perhaps much more quickly renewable. They do have an overall low carbon footprint, but are harder to source because they are from limited locations. So if we're looking for a more circular alternative than MDF, we know we can't recycle MDF or plywood. What else can we use? Okay, so there've now been a group of construction panels now being manufactured out of waste plastics. Now, of course, we understand that plastics have a challenge, but the good thing about these are 100% waste plastic, recycled plastic content. They're put together in panels. They have good stiffness. You can put a screw into them. They laminate well. And at the end of their life, you can then recycle them back into more panels. So they have that circularity. It's a good example as well here. We've got one from instead of plastic waste, it's actually got fiber waste, so fabric fiber waste. So this also offers that option of using 100% recycled content and then potentially recycling back into more textile boards. So that circular story. They offer a wood-free option. There is, of course, the challenge that we are working with plastic. So there's the option, when working with them and sawing and cutting and that sort of thing, they are going to create a small amount of microplastics, but it is small. They do tend to be slightly more expensive, and they are limited in their location of manufacture and sourcing. So if you want some, you have to order them directly from the suppliers. Slight variations in performance, but they do offer a good alternative if you're looking for a more fully circular solution. So 4 examples I had. EcoPly, EcoSheet, there's a material called Really Solid Board, which is actually from Denmark. And there's a product from the US called Everboard as well. Not quite as stiff, but can be used in more basic construction, used in flooring, used in roofing as well, all from 100% recycled material. Again, allowing for that complete circularity. Not particularly low carbon footprint. Remember I mentioned the difference between the two. You've got the challenge of is it going to be fully circular, or is it going to have a higher carbon footprint? In this case, if I want to go circular, then I've got to have a slightly higher carbon footprint. One of the challenges and trade-offs you have. With glass and plexiglass, clients ask me, okay, well, I need something which is not plastic and not heavy and breakable, but still has transparency. And unfortunately, these are the only 2 things we have right now. Unless, we're moving towards transparent wood, but we're not quite there yet. So at the moment, it's glass or some other transparent plastic. Carbon footprint for glass is mostly lower, but the challenge is when, a lot more of it breaks. So, that then brings the footprint up. So in overall carbon footprint, glass is lower than plastics because it's just such an energy efficient process. It is also possible to get 100% recycled content panels with transparent panels, and I'll show you those a little bit in a bit. And also, they can be recycled, both the plastic and the glass. The challenge is you need to send them back clean. You can't coat them. You can't put anything else on there. Can't be a whole bunch of dirt on the plastic. There can't be a whole bunch of rubber cement and that sort of thing on the glass. You've got to send them back clean for them to have any potential for recyclability. So acrylic, plexiglass, that sort of thing. There are bio-based versions, but not 100% bio-based, 25 to 35%. You can search those out. There are also a couple of versions with completely recycled content. There's an Italian one called MaterialConneXion. There's one over in Mexico, and now more recently there's been one in Japan. No real concern with toxicity. Circularity, the companies who produce these 100% recycled content acrylics, they will actually take panels back, but of course you've got to ship them to Mexico, Italy, or Japan, which is not really viable. So better perhaps to look for your local recycling plant, see whether they will take the clean versions of the things you're trying to recycle. Selection includes Green Cast was the one from Italy, Eco Green is from Mexico, Eco Acrylic XT I think is from the Netherlands, Proterra is from Germany, and Recycle PC is a US version. So the top two have 100% recycled plastic, and they come in clear and all sorts of different colors. They're a wonderful solution. As I said, they 100% recycled content can be recycled, but it's hard to ship them back to where they came from, so better to find a local recycler to do that. For glass, it's always been a challenge. And we always say that glass is 100% recyclable and infinitely recyclable as well. However, the challenge is that most glass isn't recycled, most glazing glass isn't recycled back into glazing. There's a bit in there, 10 to 25%, that comes from post-industrial within the plant itself. But anything that's out there for glazing that you've installed isn't going back into the plant. It's just not clean enough. So it ends up in roads as fill, etc. We know it's got no renewable content. As I mentioned, 10 to 25% post-industrial cycle content. No real concern about toxicity. And as I mentioned, it can be recycled, but most of it is basically going into lower quality solutions. As I mentioned for the acrylic as well, keep it clean, but there's a potential to upcycle it. And there have now been solutions which are zero carbon footprint as well, which I think is great. So carbon neutral. Saint-Gobain is a great example of this. They've just in France, they made their first solution, which is actually carbon neutral. Great step forward because it's quite an energy intensive process. Other companies are going to try and follow suit. So it then has the option that you've got a inert material, carbon neutral, and it has the potential to be recycled back into something else, not always back into glazing. With metals, we know again we can infinitely recycle these materials, and that's great, and we do that. And the majority of the metals that you use are between 50 and 90% recycled content already. So metals, even though they have a lot higher carbon footprint than all of the other solutions, if I'm going to use metal rather than plastic, expect my carbon footprint to be 2 to 5 times higher than my plastic. That's a challenge, but they do have a great option for circularity. We know there's a viable and successful recycling process for almost all metals. In general, most of the things like paints and glues doesn't really matter because they get burned off when the material is melted. So unlike glass, unlike plastics, unlike all other materials, I don't mind if it's getting painted. So in any solution, I can paint the metal, I can put all sorts of different surfaces onto it, and it's fine. One thing that I mentioned as I go through this, though, of these solutions here where we've got even lower carbon footprint versions, I've got aluminum at the top, I've got a stainless, I've got a regular steel, and I've got a brass. All of these have either very low carbon footprint or carbon neutral. And I think that is also a good solution. The challenge is at the moment for us as consumers, they're not getting down to us. So Outokumpu, which is producing carbon neutral stainless, is currently selling into the automotive industry. So although carbon neutral stainless steel exists, it's only being sold to larger corporations. So eventually it's going to filter its way down to us. It's just going to be a few years before there's enough material there for us to get our hands on. So, zero plastic, fully circular through recycling, carbon footprint's coming down. It's just managed it through carbon neutral for some solutions, but not quite to our industry yet. With textiles, I know there's a lot out there. So, a lot of you are using an awful lot of these. It's very hard to say which is the best. Obviously we can use the natural fibers, the wools, the silks, even now more so hemps, these things such as that. The challenge is they do actually have quite a higher carbon footprint through the manufacturing process. And the challenge also is that when you're using these natural fibers, because of their perhaps reduced high performance attributes, sometimes people have to coat them or treat them in different ways that perhaps is not ideal. So, for lower impact areas, definitely if you can use the natural fibers. But we're now seeing an awful lot more recycled content, both in nylons and polyesters. Not so much in acrylics. Acrylic is very hard to recycle in a standard way. It's possible to do it in sheets, but that requires a specific chemical process. But it's actually So acrylic, not so much, but certainly the nylons and polyesters. There's a great number of solutions out there now. We've got 100% recycled content that allows us to use a zero virgin plastic. And I mentioned at the bottom here, compostability. You can compost fabrics. The challenge is it's just the speed at which it happens. So it's very, very rare that anyone actually takes any sort of fabric and puts it in the ground. So it is possible, it's just not really done. As I mentioned, they'll have a lowish carbon footprint. Wool can be, recycled wool definitely has a low carbon footprint. The challenge, of course, with the recycled polyester and nylon, it's not zero plastic, even though it's zero virgin plastic. I mentioned hemp there just because we're getting a lot more of these types of fabrics. It's a very popular material to be sourcing right now. It's had a lot of new fabrics out there using that material. With flooring, overall, it's a standard sort of look at flooring. The idea is basically that wood flooring is best, wool carpet's worst, simply because the amount of time it takes to actually work with it. It takes an awful lot of maintenance, doesn't last as long, etc. But it just in general shows that in terms of sustainability, wool carpet is the worst. But if you think about circularity, it becomes one of the best. So again, that difference between sustainability and low carbon footprint, and then the ability to make it circular. So I mentioned carpets, some of the highest carbon footprints, mainly due to maintenance and longevity. The actual overall production is pretty low. It's just in its use. So, of the ones that I would recommend, undyed wool is probably the best, using a latex glue. We started to see some bio-based synthetics, though. There's a bunch of material that are using sugarcane as a renewable content, only 37%, but it's getting up there. And there's also been some great recycled nylon carpets with the potential also to recycle it back into more carpet. There's been some great developments with recycling carpet now. There's one here in the US. There's one also over in Europe as well. So the recyclability of synthetic carpets is now possible, allowing us perhaps to move towards more circularity, even with synthetics, and that will be using recycled content in your carpet to start with, and then recycle it at the end of its life. I also wanted to include PVC as well, just because it has a bit of a bad rap, but I think that sort of durable hard flooring that has a flexible, it's hard, but it's flexible. I think some of it has a bit of a bad rap, so I want to include some new options here if you're thinking about PVC flooring. Some versions with 100% renewable content, which is great. Some recycling going on, not an awful lot, but some of the big suppliers are now taking back their material. However, the challenge is, again, it needs to be glue-free. It can't have any sort of dirt on, a sensitive amount of dirt onto it. It needs to be relatively clean for them to take it back. And within increasing to enhance circularity, if you can use recycled content, do it. Other materials might be linoleum, which of course is ultimately biodegradable. It might take a while, but that at least is a 100% renewable resource. So overall, recycled, linoleum, rubber flooring is a little tougher, just because it does contain plastic, and also that it has it doesn't really have any circularity. But there are some within PVC flooring. There's also some bio-based versions as well. And then finally, solid surfacing. This one, whenever you look in the industry periodicals and you look at newsletters, etc., almost everyone's always trying to find that sustainable alternative to solid surfacing. So ignore the dye bond bit at the top. So this is solid surfacing material. So the three main sort of ones are recycled content polyester, recycled paper laminate, or alternatively, you could some sort of a harder or metal sheet. So at the moment, the challenge with this is that there's no real great solution. If I'm using metal, great. But for a little bit more warmth, I'm using recycled content, whether it is using the polyester type materials such as Durat, things like that, or whether I'm using a rich light or paper stone version. So what that really shows is that within solid surfacing, we don't have a great solution for circularity. The only way to do it currently is to basically use a metal, which you don't really always want to use as a surface, a little too cold. So within those, we're starting to see higher recycled content within the material, but there is a limitation. So with my my recycled content polyester, solid surfacing, my pressed paper, recycled paper laminates, those sorts of things. It's 50–60% is about maximum we're getting, and there's no real end of life for those. I can burn the rich light and I can burn the paper stone. I can't really do much with the recycled content polyester panels. Durat does offer recycling, but I've got to take that solid surfacing and sending all the way back to Europe, which is not really viable. So although we've got some good amount of recycled content, there are challenges with end of life. So just as a sort of as a final note, I want to, taking you through a number of different materials. That's why I said approaching circularity at the start, because of course we are looking to try and make these things more circular. The challenge, and I think at the start we're doing well. So we've got recycled content, we've got renewable content, we're doing great things at the raw material stage. Durability and use is great, but our end of life is still our challenge. I can pull a solid surfacing material out, I can pull out some flooring, then what do I do with it? We're seeing more and more companies actually adopting a take-back program, and that is great. And I would, look for those sorts of initiatives when you're purchasing it, thinking about at the end of its life, okay, I purchased this material, I know that as long as I keep it clean, then basically at the end of its life, I can give it back to that brand. So that's a great solution. For a lot of the other ones though, we're still in the early stages of finding viable ways to reuse these things effectively.